Hi everybody, this is Eduardo Suarez. This video is going to be dedicated to KAREL programming. Today we're going to apply what we have already learned about KAREL programming from my previous tutorials, and we're going to have fun implementing a TicTacToe game. This is going to be a very simple program, and the objective of this video is to get more familiar with KAREL programming. We're going to be using many of the instructions that I have already explained on my previous tutorials, such as screen control, user-defined data types, and routines. So if you haven't seen my previous KAREL videos already, I invite you to watch them so you can understand the instructions that we're going to be using here. I'm going to divide the video in two parts. On the first part, we're going to program the TicTacToe game that runs manually, so you will have to input the position for both players. And on the second part of the video, we're going to implement the MiniMax algorithm, and the robot is going to play by itself. By the end of the second part of this video, you're going to be able to implement a KAREL program that looks like this. We're going to control the user screen 1 on the teach pendant, and we're going to have a selection button to start or finish the program. When the selection is made, the robot is going to start playing. And we have in here the possible positions for the board. So now is the time for the player to select a position. We're going to select, for example, position 1. The robot is going to play again. We're going to block the robot with position 6. And now we're going to block the robot with position 5. The interesting thing is that when we implement the MiniMax algorithm, the robot never is going to lose, either it's going to win or it's going to be a tie. I'm going to start by explaining briefly the MiniMax algorithm, and for that there are two excellent videos on YouTube. I'm going to leave the link to these videos in the description below. The first reference explains the MiniMax algorithm in more details, and the second and third reference explain the TicTacToe game using Python programming. I use this Python program as a reference, and I translated that to KAREL programming. To show you how the MiniMax algorithm works, we're going to start with a predetermined condition like the one shown in this diagram. The maximizer player is using O, and the minimaxer player is using X. For every play, we will have to determine the evaluation for that move, and here is where we need to use an algorithm to calculate the outcome. Since this is a very simple game, we're going to be using +1 if the maximizer wins. We're going to use -1 if the minimaxer wins. And we're going to use 0 if there is a draw. In the MiniMax algorithm, the idea is that both players have opposite interests. The maximizer, as the name implies, tries to maximize the score, and the minimizer player on the other side tries to minimize the score. So the maximizer will select the move that gives the highest score possible, either +1 or 0, while the minimizer will select the move that gives the lowest score possible, either -1 or 0. In this diagram is the turn of the maximizer player to move. It has 3 possible moves to make, and we're going to represent the moves with the branches as shown in the second level. The first move is going to lead to a win, and this is going to be +1. And the second and the third move, this is going to be undetermined at this moment, so we need to keep evaluating further down. At this point, on the level that's shown in here, is the turn of the minimizer player to play. So the minimizer in here, it has 2 possible options, and for the other move, it has also 2 possible options. We're going to start evaluating from left to right. For these 2 positions of the minimizer player, there is not an outcome yet, so we need to keep evaluating 1 level down. And for these other 2 positions, there is a win on the right with a -1. So we have already scored for the minimizer player. On this level is the turn of the maximizer to play. So the maximizer can select each one of the positions shown in here. From left to right, this position over here is going to lead to a win to the maximizer, and the other two positions is going to lead to a draw. And this is the final level when we end the game. Now that we have the evaluation for all the possible positions, we need to move this information one level up. The minimizer is going to select the position that leads to a lowest score. So from +1 and 0, the minimizer is going to select the position that leads to a 0. And from these two positions on the right, the minimizer is going to select the position that leads to a -1. So now we're going to move this information one level up again. Now it's the turn of the maximizer to play, and the maximizer is going to select the position that leads to the highest score possible. So never is going to select these two positions over here, because either it's going to lose or it's going to be a draw, while it has this other position possible that's going to be it's going to lead to a win. So from all these three possible positions, by using the MiniMax algorithm, the maximizer player is going to select the position that leads to a win. So in a nutshell, that is what the MiniMax algorithm is doing, is trying to determine the best possible outcome for the maximizer player. In this example, we went further down to the bottom of the layer, where we exhausted all the possible moves. In practice, this is not always possible, because doing that would require a very high volume of calculation. In that case, you will have to limit the number of levels that you want to extend further down the calculation. And I'm going to show you later how that is done. Now I'm going to show you how the TicTacToe game is implemented using KAREL programming. Again, on this first part of the video, I'm going to implement the basic game, and on the second part of the video, we're going to implement the MiniMax algorithm. We're going to start by creating a new work cell in Robot Guide. We're going to give it a name. We're going to press next. We're going to select the software version. We're going to press next. We're going to press next. And over here, we're going to select the KAREL option package R632. And we're going to press finish. Once the work cell is created, we're going to select files. We're going to right click. We're going to select set default folder. And we're going to make sure that the folder that we're selecting is going to be the work cell TicTacToe. We're going to create our first KAREL program. We're going to select files again. We're going to right click, and we're going to select new file and KAREL source. By default, it's going to create a blank program that's called Untitled1. And as a reminder, the structure of the program is going to be something like this. We're going to have a header that is program, and we're going to have an end, and then we're going to have a section that is called variables, where we have the declaration section of the variables for the program, and we're going to have a section that starts with begin, where we're going to have the executable section of the program. The first program that we're going to create is going to be the definition of the board. So we're going to call it board definition. And here we're going to have the translator directives. We're going to define a constant that's going to be dimension, and it's going to be a value of integer 9. And this is going to be the dimension for the array. that we're going to define over here. We're going to use instruction type to declare a user-defined data type. We're going to define board data. That's going to be a string with one character. And then we're going to define the board array. That is going to be an array of dimension 9 of type board data. So basically, we are creating an array of strings. Which one of the strings is going to be just one character. And the length of the array is going to be 9. Now we're going to define the variables. We're going to define a variable that's called board. That's going to be type board array, as the one that we have defined over here. And we're going to have another one that's going to be board element. That's going to be type board data. That means it's going to be a string of one character. And then we're going to define another integer that we're going to use as an index for the for loop that we have in here. So over here, we have the executed section of the program. The first thing that we're going to do is going to be initialize the variable that we have declared over here, the board element. And we're saying that this is going to be a space of one character. And then we're going to have a for loop that goes from 1 to the dimension. And we're going to go through each one of the elements on the array. And we're going to initialize the elements to a space. And this is all that is doing this program. We're going to save our KAREL file. We're going to select Save As. We're going to select the folder for the work cell. And we're going to change the name to board definition. And the next thing that we're going to do, we're going to build the program. We build the program. We didn't have any faults. And if we expand the files folder, you're going to see that we have two files. One is going to be extension KAREL, and the other file is going to be extension PC. And this is the executable KAREL program. So now we can open the teach pendant. We can press select. And we're going to find the KAREL program in here, board definition. We can execute this program. We're going to select the file. We're going to press enter. We're going to press shift and forward. And the program was executed. What we can do now, we're going to select the file. We're going to press data. We're going to select type. We're going to select KAREL variables. And over here, we have the variables for our program board definition. We're going to have the variable board, that's type board array. We're going to have the other variable, that's board element, that is type board data. And we have our integer I. We can look at board. If we select over here, we can press enter, or we can press detail. And we're going to go one level inside the board. You can see here that is an array of 9 elements of type board data, as is defined over here. We can press detail again, and we're going to go one level inside the array. So here you can see the 9 elements of the array. In KAREL programming, the array starts with 1. So we're going to have from 1 to 9. And each one of the elements is a board data type. And we can press detail again. And this is going to have one character that is going to be a space. We're going to create our second KAREL program. This is going to be our tic-tac-toe game. And the first thing that we're going to do, we're going to declare the same variables that we had in the board definition. That's going to be the constant, it's going to be the user data types, and we're going to have our variables. So what we're doing is we're sharing the variable board from the program board definition. And then we're going to create two more variables. That's going to be endgame and program index. Over here, we're going to start creating our routines that we're going to use on the executed section of the program. The first routine that we're going to create is going to clear the screen. And this routine consists of an instruction that's called routine with the name of the routine and instruction N with the name of the routine. So over here is going to be enclosed the declaration section and the executed section for the routine. We don't have any variables declared in this routine, and the only thing that this routine is doing is going to clear the screen on the teach pendant, and it's going to force the screen user 1 on the teach pendant. Now we're going to create another routine that's going to be print board, and what it's going to be doing is going to print the board on the screen on the teach pendant. In KAREL programming, we have two kinds of routines. We have the procedure routines that they don't return any value, and we have the function routines that they return a value, as we're going to see later. So for now, this is a procedure routine. What we're doing here, we are defining the parameters that we're going to pass, and we're going to pass the board. And what it's going to be doing is going to clear the screen, and it's going to print the board. We can test the program up to now. What are we going to do? We're going to select over here in the executed section of our program. We're going to insert these instructions. This is going to be calling the program board definition, and then we're going to call the routine print board, and we're going to pass the board. So when we execute this program, it should print the board on the screen. We're going to save it, and we're going to build it. We're going to open the teach pendant. We're going to press select. We're going to look for our TicTacToe program. We're going to press enter, and we're going to press shift and forward. And what it is doing is opening the user screen, and it's going to print the board. And you can see here, this is the elements of the board with each one of the numbers for the elements. And over here is the board that we're going to use in our game. So the program is working up to now. We're going to continue adding more routines. We're going to add a routine that's going to check for draw. We're going to call it check for draw. And we're going to pass as a parameter the board. And this is going to be a function routine, so it's going to return a boolean. We're going to define some variables. We're going to define the index that we're going to use for the for loop. We're going to define an integer that's going to be dimension, and we're going to define a boolean that's going to be draw. On the executed section of the program, we're going to initialize the variables. We're going to initialize the dimension to the length of the array board that we're passing as a parameter on the routine. And then we're going to initialize draw as a true. The purpose of this routine is determined if we finish with the game. If the game is finished, we shouldn't have any space on the board as an element. So we're going to search through the board. We're going to use a for loop, and we're going to go from 1 to the length of the board, and we're going to check for each one of the elements of the board if there is a space in there. If that is the case, the draw is false. That means that we haven't finished with the game yet, and at the end of the for loop we're going to return the value for draw. So we're going to use the instruction return. That's going to be the value that we're going to return over here for the function routine. So the moment that we call this function routine, this is going to be return a value of true or false. And I missed something else in here. That's going to be the end of the routine. We're going to create another routine. We're going to call it check for win. We are going to pass as a parameter the board. And again, this is going to be a function routine, and it's going to return a boolean. The variable that we're going to define over here is going to be win. That is going to be a boolean, and this is the value that we're going to return on the routine. On the executable section of the program, we're going to initialize win as a false, and then we're going to check for any condition that leads to a win. So we're going to check on the first row. We're going to check for each one of the elements from 1, 2, and 3 if they are equal, and at the same time if they are different from a space. In that case, that means we have a win, and the value is going to be true. And we keep doing the same. We're going to check for the second row. We're going to check for the third row. We're going to check for the first column, the second column, the third column, and then the 2 diagonals. And at the end, we're going to return the value for win. We're going to add another routine. We're going to call it check position, and the parameters that we're going to pass is going to be the board, and we're going to pass the position that we are selecting on the board during the game. And it's going to return again a boolean. The objective of this is going to check if the position that we are selecting during the game is a valid value, and also if the position hasn't been selected yet. We're going to define 3 more variables. It's going to be the dimension, valid number, and valid position. And on the executable section of the program, we're going to initialize the variables. Dimension is going to be the length of the array for the board, and we're going to initialize the valid number to false and the valid position to false. The first thing that we're going to check if the number that we are entering is a valid number. Should be an integer from 1 to 9. That's going to be the dimension of the board. So if this board position is greater than 0 and is equal or less that dimension, the number is valid. So we're going to have a valid number equal to true. And then we're going to check if the position that we are selecting is empty. That means that we're going to check for the position inside the board that has to have a space. And in the case, the variable valid position is going to be true. And at the end, the only thing that we're interested in returning is going to be the valid position. We're going to add another routine. We're going to call it insert letter. And the parameters that we're going to pass is going to be the board position, and a letter that's going to be either X or O, and this is going to be a procedure routine, doesn't return any value. We're going to declare as a variable dimension. Again, dimension is going to be the length of the board. What this routine is going to be doing, the moment that we pass the board, we're going to select a letter and we're going to select a position. So we're going to first check if the position is valid. If we have a true value as a return of the call for the check position, we're going to insert the letter on the position selected on the board, and we're going to print the board again. Then we're going to check if we have a draw. In that case, if the draw is true, we're going to print a message that says draw, and we're going to exit the if. And finally, we are going to check if this is a win and it's not a draw, and then we're going to print robot wins in the case that the letter selected is X, or we're going to print player win in the case that the letter selected is not an X. And if this condition is not valid, we're going to come this way and we're going to write selection invalid and enter new position, and we're going to read the new position in here, and we're going to call the routine again. Something that you can notice in here is that inside a routine, we can call another routine. In this case, inside the insert letter, we are calling the routine check position, and we're calling the routine check for draw. Something you have to notice is that you have to define the routines before you call them. And the other thing is we are going to do a recursive call to the same routine. So inside the insert letter, we're going to call again the insert letter routine. We're going to add another routine. We're going to call it player move, and we're going to pass the board. In this case, we're going to define two variables. It's going to be the board position and the player. That's going to be a string of one character. We're going to initialize the player to the character O, and we're going to write the message. It's going to be enter the position for O, and we're going to read the position, and then we're going to call the routine insert letter, and we're going to pass the board position and the player, and we're going to end the routine. In the same way, we're going to create another routine that's going to be robot move. It's going to be exactly the same as the one that we have for the player, and in this case the only difference is going to be we are defining a variable that's going to be robot, and it's going to be a string of one character that's going to be X. And the moment they call the routine insert letter, we're going to pass the X instead of passing the O. So with this, we added all the routines that we need for our game. The last thing that we're going to do, we're going to go to the executed section of the program, and we're going to add the new lines. We're going to initialize the variable in the game. We're going to put the value of false, and then we're going to do an infinite loop that is going to start with a repeat and until the end of the game. Over here, what are we going to be doing? We're going to be calling the routine for the robot mode, and then the routine for the player move. The moment we call the routine for the robot move, we're going to check if we have a win or if we have a draw. In that case, we're going to change the value of the variable in game to true, and otherwise, if we are not at the end of the game, we're going to call the routine player move, and we're going to check again if there is a win or if there is a draw, and in that case we're going to set the end game to true. We're going to keep repeating this loop until we reach the end game equal to true, and at that moment we're going to put a delay of 15 seconds. And with this, we have concluded with the coding for the game TicTacToe. We're going to make a small change. We're going to go back to the insert letter routine. And over here, we're going to change the order for this. So we're going to delete it. And we're going to set it again. So now we're going to check first for win. And then if we have a draw and we don't have a win, we're going to write draw. Now we're going to save it. And before we build it, we're going to open the teach pendant. We're going to select any other program that is not the TicTacToe. And we're going to build it. And we didn't have any faults. Now we're going to create a new program. We're going to call it Start Game. We're going to clear our variables, and we're going to call the routine clear screen from the program TicTacToe. On the executed section of the program, we're going to copy these instructions. We're going to call an infinite loop with a repeat until instructions. We're going to call the routine clear screen. We're going to write the message, do you want to start a new game? And we're going to prompt the user for pressing F4 to start the game, or F5 to finish the game. On this instruction over here, we're going to home the cursor and we're going to clear to the end of the line. This is another way of clear the screen. Then we're going to set the cursor to the function section of the screen on row number 1 and column 26. And we're going to write yes. And then we're going to move to the column 34 and we're going to write no. And then we're going to wait for the user to press the function key Shift F4 or Shift F5. If the user presses the key Shift F4, we're going to call the program TicTacToe. Otherwise, we're going to abort the program. Noticing here that we're using the translator directive include with the name of this file, and this file is located on the folder for the work cell. We're going to go to Tools. We're going to open the folder for the work cell. We're going to select Robot1 folder, and we're going to open the support file. And over here, you're going to find the file that we're using over here. And this folder is created automatically the moment that you create your first KAREL program and you compile it. We're going to save the program and we're going to build it. We're going to go back to the teach pendant. We're going to select the program Start Game. We're going to press Shift and we're going to press forward. You can see here that it opened the user screen and we have the message over here, do you want to start a new game? And it's prompting the user for pressing the functions key F4 or F5. In our case, we're going to use the function keys Shift F4 and Shift F5 because we have already pressed the Shift key. Otherwise, the moment that we release the Shift key, we're going to stop the execution of the program. And on the teach pendant, you're going to have the keys F4 and F5 over here. So what I'm going to do, on the keyboard of my laptop, I'm going to press the function key F4 to start a new game. First, it's going to be the turn of the robot to move. So we need to select a position. We're going to select position 1. Now it's the turn of the player to move. We're going to test the program and we're going to select the same position. It says that the selection is invalid. We're going to select another position. We're going to play for the robot and we're going to select position 7. We're going to block the robot with position 4. We're going to select position 9 for the robot. We're going to block the robot with position 5. And finally, we're going to select position 8 for the robot. And the robot wins, and it's the end of the game. The program is going to wait 15 seconds, and it's going to go back to the start game KAREL program. And this time, we're going to press the function key F5. In conclusion, the objective of this video was to show you, using a very simple application, how to apply some of the functions and instructions that I explained on my previous tutorials. Probably the most interesting thing in this application was to show you how to use routines. We use the function routines and the procedure routines. I show you how to call a routine inside another routine, and also how to call routines recursively, such as the insert letter routine that on the executed section is calling itself again. Also, we can use routines that we have created in one program and call them from another program, such as a clear screen routine that was created on the TicTacToe program, and we were calling that from the start game program. Routines are a powerful way of making a program more modular, easier to understand, and also easier to troubleshoot, and it's going to help you to make your program to look more professional. In addition, I show you how to use the user-defined data types, and although I haven't covered that on this video, you can expand the user-defined data types to create the structures, and basically structures are a collection of user-defined data types. On the second part of this video, we're going to adapt this program to include the MiniMax algorithm. You're going to find that there's just a few changes that we need to do, and you should be able to do that by yourself if you follow the link to the reference tutorials on the MiniMax algorithm. That is all for now. I'm going to leave the link to the work in the description below, and thank you for watching.